Okay, now let's continue with the next questions about angular displacement. The first question is the question in the book, which is about this chart, as you see. Delta theta is given in degrees, and delta S is given in radian, sorry, in meter, and what is R in meter? So we know how to calculate delta theta. If delta S and R given, delta theta is equal to delta S arc length divided by radius. So we are going to calculate R, so cross product, replace R and delta theta in these types of operations. R is going to equal delta S over delta theta. So delta S is known in a SI unit meter, but delta theta is given in degree. So we have to convert degree to radian first because radian is a SI unit, not degree. There are multiple ways to converting the degree to radian, but the easiest way, shortest way is if you divide, if you want to calculate any angle in radian, so divide angle in degree by 57.3, which is equal to 1 radian. So when we divide 125 degrees by 57.3 degrees, so you will calculate the corresponding angle in radian. 125 divided by 57.3, it's going to be 2.36 radian. Now that we can continue and find what is the radius. Delta S is 2.6 positive. Delta theta 2.36 positive. 2.6 divided by 2.36, which is going to be equal to 1.1. That is equal to 1.1 meters. So is the correct answer. And question number 2. A beetle sits at the top of a bicycle wheel. So assuming the wheel turns clockwise, which is the negative, what is the beetle's angular displacement, which corresponds to an arc length of 1.2 meters, and the wheel's radius is 40 centimeters. So this is delta S. But for clockwise rotation, delta S is going to be negative 1.2 meters. Radius 40 centimeters, but we should use SI unit for lengths in calculation, which is 0.4 meters. And 4 centimeters divided by 100. Then we can calculate what is the corresponding angular displacement. Delta theta is going to be delta S over R. Delta S, negative 1.2. R is 0.4. Result is, let's do it, divided by 0.4. 3. This is negative 3 radian. But as you see in the choices, there are radian and also revolution, but in radian we don't have the correct answer. Or negative 0.3, 30, and also 0.377. So, but there's one revolution. Maybe choice is C. Let's check it. To convert radian to revolution, we have to divide every one revolution is 6.28 radian and 2 pi radian. So if we divide angle in radian by 6.28, we will calculate corresponding angle in revolution, 6.28. So 3 divided by 6.28, it's going to be negative angular displacement in revolution is going to be negative 0.477 revolution. As you see, choice C is the correct answer. And question number 3 and 4, in fact, very close to each other. 3 is the easier one. When a wheel is rotated through an angle of 35 degrees, so which is delta theta in degree, a point on the circumference travels to an arc length of 2.5 meters. Traveling circumference It is delta S, arc length. This is delta S is 2.5 meter. What is the radius of the rail again? We will use the equation delta theta is equal to delta S over R, but R is the question. So cross product and replace delta theta and R. R is going to be delta S over delta theta. Delta is says in meter a SI unit, but delta theta is given in 35 degrees, which is not a SI unit. We should convert 35 degrees to radian first. Angular displacement in radian is going to be easy way, is the most practical way. Divide this angular displacement in degree by 57.3, which is equal to 1 radian. So 35 degrees is divided by 57.3. How much is it? Let's get 35 divided by 57.3. It is 0.61. 0.61 radian. And now we can calculate how much is R. R is equal to delta S over delta theta. Delta S is, now we got in the question 2.5. Delta theta in radian is 0.61, which is at the same time equal to 35 degrees. 2.5 divided by answer, which is 4.1, almost 4.1. 4.09, but then you round it, you go for 4.1 in these questions, and choose always the closest answer to your answer, your calculation. It is the correct answer. And question number 4 is similar to 3, but one more step to the two-step problem is this. When a wheel is rotated through an angle of 35 degrees, a point on the circumference travels through an arc length of 2.49 meter. And in fact, this is the part of the question Question 3. What is the angular displacement of the same point when it travels through an arc length of 143 meters? So there are in fact given two arc lengths. One arc length is 2.45 degrees, which is delta S1. I am going to say this. And this delta S1 corresponds to an angular displacement delta theta 1. And the same point, because question says the same point, and this radius for this point when it's moving a circle is the same. And you are going to calculate first radius from this given first information, and after that you are going to use this radius for calculating the arc length upon angular displacement and delta theta 2 for second arc length and delta S2. So first calculate R from the first given part. In here again 35 degrees. In fact, we did in this question 1, in question 3. Yani, R is going to be first calculate delta theta 1 in radian. 35 degrees divided by 57.3, which is we calculate in question 3, which is equal to 0.61 radian. After that, calculate R for this point, which is on a circular path, delta theta 1 divided by delta S1 divided by delta theta 1, which is equal to 2.49 divided by 0.61, which is equal to, as you calculated in question number 3, 4.1 meter. Same point this time, moves 143 meters arc length. Calculate delta theta this now, and calculate delta theta 2. Of course, we should divide delta S2 by, again, the radius, same radius, because same point. Every same question says same point, radius must be the same. So delta S2 is 143 meters. R is calculated 4.1. So now let's divide 143 divided by 4.1. Result is 35 radians. Yes, true. That's 30.8, 34.9 meters. Of course, when you round it, it's going to be 35 radian, not meters, radian. So is the correct choice for this question.